Okay, so today we're going to do electron configurations. They're a lot less time consuming than orbital notations. They're easy, but they're a shorthand version of showing the electrons. So they're going to look like this. What does an electron configuration look like? So they are going to look like this, where you have this little shorthand going on. So 1s, 2 is how you would say that. And that means in the first energy level, sublevel S, there are 2 electrons. So the number in front of the letter is the principal energy level. The letter is the sublevel, and the exponent there is the number of electrons. So if you're given a long electron configuration, if you add up the exponents on all the sublevels, they will add up to give you the atomic number of the element, and then you can look up the element and its atomic number and find out what the element is. So like if we were to figure out, well, what element is this that we have? It has 2 electrons, so that means the atomic number is 2. And so that means that this would be the electron configuration of helium. All right, you're going to need your off-bell chart for this and your ISN, and you're going to do some practice problems in your ISN. I'm going to switch to my Elmo, so give me just a minute to get out of this thing. Let's end this. I'm getting out of, don't save any of those. And let me get to my Elmo. Alright, great. Alright, so electron configurations, again, you're going to be needing your off-bell chart. And we're going to do carbon. We've already done the orbital notation of carbon. Now we're going to do the electron configuration. If you did not write down the information from the previous slide, you need to go back and get that in first. Alright, so we're going to do carbon. And again, carbon's atomic number is 6, so that means that it has 6 electrons when neutral, and we're doing these all neutral elements. Alright, we're going to be looking at this. We're going to use off-bell, and again, we always start at 1s. So 1s, and the maximum number of electrons that can go in an S sublevel is 2. So now I have 2 electrons, and now I'm going to follow my card. So 1s, and I follow this around, and I come to 2s. So I'm in the second energy level, sublevel S, and S can hold 2 electrons, no more than 2, only 2. So now I'm up to 4 electrons. Now I'm going to follow the off-bell chart, and it says my next set of electrons are going to go into the second energy level, but they're going into the P sublevel. And I need 6, and I've already got 2 plus 2, it's 4, so I need 2 more to make a total of 6. So 2 plus 2 plus this exponent 2 here. All those exponents added together equal the atomic number 6 for carbon. Alright, the next thing, so that is your finished electron configuration for carbon. Just to recap, S is the highest number that you can have as an exponent is 2. P, you can't have any more than 6. You can have lower than those, but you can't have a number greater than 6 on a P. You cannot have a number greater than 10 on a D, and you cannot have a exponent greater than 14 on an F. You can go lower, but these are the maximum number of electrons for those sublevels. Okay, so let's do potassium. So potassium, again, we're starting at 1s, it needs 2 electrons. It needs a total of 19 electrons. And I'm going to follow my chart to 2s. And S is max is 2. So that's filled. So now I can move on to 2p. And p can hold 6. So now I'm up to 2 plus 2 plus 6. So that's a total of 10 electrons. I'm trying to get 19, so I need 19 more. So, oh, by the way, you can't move off of one of these sublevels until you fill it completely up. So, with a maximum number. So I can't just put 4 here and then move on to the next energy level. I have to fill up this completely before I move on. So this is 3s, which is next, and it has 2 electrons. So it's filled completely, and then I move on to 3p, which has a total of 6 needed. And I did need all 6 of those because I'm at 2 plus 2 plus 6 plus 2 plus 6, which is 18 electrons. We stopped right there. This would be the electron configuration of argon. And then my next one, I would need 1 more to make 19. So it says to go to the 4th energy level, sublevel S, and I just need 1. So that makes that potassium. Alright, so do arsenic. Pause the video, do arsenic, 33 electrons, and then come back and check your work. Alright, now, again, we're starting at 1s on all these, so we're going to go through 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then after 4s2, you should have gone to 3d. You need a 10, that makes 30 electrons, and then after 3d, 10, you would go to 4p, and we don't need 6 electrons there because we only need 3 more, because 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 equals 30. So I just need 3 more to equal that 33. So you don't have to fill up the sublevels with the maximum number of electrons if you don't need it. Only, and that's for the very last one, only if you're trying to move to a different energy level and sublevel do you need to have it filled up completely. Alright, now the only problem with this is that my 3s are not together. So you follow Aufbau's chart, and then what you want to do after that is reorder those. To reorder it, you want to put all the 3 third energy levels together and then move this 4s over here. But you follow Aufbau's chart first before you do this. And then this is the reordered energy level, so that's putting all your electrons. 10, 4s2, 4p3. Alright, so this is the first energy level. Here are the electrons in the second. Here are the electrons that are in the third energy level. Here are the electrons in the 4th energy level. This is the highest number, principal energy level number, 4. So these are your valence electrons. 4, 2 plus 3 for a total of 5 valence electrons for arsenic. And again, we could use our shortcut, but we didn't need that. So you've got some of those to practice in class when you get to class, and that's how you do these. Thanks and have a great day.